Good afternoon, everybody. This is Gene Bohensky at IR Thermal Systems. Welcome to our webinar presentation today entitled Choosing the Right Heating Technology for Your Process. So tailored heating solutions to increase line speed and production throughput. So this is intended to be kind of like an introduction webinar to our company and to the different heating process technologies that we implement for our customers. We have a couple of our experts online that will be available at the end of the presentation for your questions. That's Cornell Palmy and Alfred Foss. They're watching, but they'll be there at the end to answer any of your technical or application questions that you might have after the presentation. So with that, let's get started. So a little bit about IR Thermal Systems. Our company was founded in 2021 after the former management team purchased the assets and intellectual property of Radiant Energy Systems and Anderson Thermal Devices. So we were formed really to carry on the legacy of the previous company. Our management team and employees have had experience since 1985 in this market. And we also serve all of our existing customers and former customers because we have heaters built and installed worldwide. So we're here to move forward. Our core competence is the design and manufacture of custom engineered process heating solutions for improving performance and lowering production costs. Our focus is always on quality and dependability for our customers. We constantly invest in the latest manufacturing technology. We produce many of our own high quality component parts. We found that's critical to control quality. We focus on continuous heating processes. And the big difference between us and other companies is that we're truly technology independent. So that allows us the freedom to choose the best heating technology for the customer's application. So how do we help with custom process heating solutions? Well, we focus on preheating, drying, and curing applications. We do hot air systems, IR systems and heaters, and combination hybrid IR and hot air systems. For our customers, we increase line speeds, we reduce energy costs, we save space, particularly with our infrared solutions. We also do a lot of troubleshooting, leveling out uneven temperature or moisture across a web. And we also just heat selected zones across the web when we just want to improve the performance of existing heating systems. So we serve a wide range of industries: converting, paper, film and foil, printing, nonwovens, plastic, adhesive lamination, batteries, medical devices, filter media is big for us, fiberglass, advanced composites, industrial fabrics. We have many automotive applications, packaging applications, wire and cable, textiles, and many other applications. So we serve a wide range of industries over the 35 years that we've been in business, that we've had experience in business. We certainly can help solve a lot of application problems. So how we work with your team. So we have a crew of specialized engineers that review your existing process. We determine the best technology to use to meet your goals. With state-of-the-art design tools, we develop a system tailored to meet your target specifications. We also have our popular low-cost infrared rental program that allows our customers, allows you to try our technology in your plant, especially since with infrared, you want to tailor that solution for your application. This allows you to do that at a low cost. We also have project specification sheets that are developed for each type of application. We provide those to our customers to provide us all the information needed to properly specify a heating system. So once again, our three major applications. First are drying. So solvent vaporization or evaporation of water, curing, the final web or coating temperature requirement, normally following a drying requirement to cure some sort of chemicals on a web, and just basic heating, raising the temperature of a product, maybe for heat set, for curing, before lamination, or just to heat 100% solids or foils. So let's look at the range of drying methods that we have available. For convection hot air systems, we focus on impingement dryers, flotation dryers, and through air dryers. For radiant heating and infrared systems, we do both electric infrared and gas-fired infrared. And of course, one of our specialties is combination infrared and hot air systems. So in our opinion, each technology has their advantages and disadvantages. Since we are technology independent, we are free to choose which is best for your application. So let's start with the different drying methods, just as an introduction. The first are impingement dryers. You can see there on the screen here how they work. You have these impingers that are basically blowing hot air onto the substrate, onto the web. You have a turbulent air at surface and a laminar layer at drying surface that heats up the web and performs what is required. So in this application of this type of technology, air is blown through a nozzle to heat one or both sides of the web. It's typically used for coated and non-permeable webs, such as adhesive tapes, protective films, coated fabrics, architectural fabrics, and other printed materials. It can be easily arranged for multiple heat transfer zones and adapted to different product requirements. And this technology also gives you an accurate and uniform control of the dryer temperature. A couple other aspects that could be seen as disadvantages. This method does require roll or conveyor support needed along with the associated initial costs, maintenance issues, and web tension requirements for longer dryers. So there's equipment that you have to maintain with this process. You have the possibility of web scratching or marking from contact with the web support idlers. And it's also slower to heat up or cool down. The next are flotation dryers. Flotation dryers are a little bit different because what happens is it allows the technology allows the web to be transported through the dryer without contact, like a non-contact drying system. So you have some specific advantage to this type of dryer. Flotation dryers direct heated air at the product from both sides, producing more effective heat transfer rates per running length of the dryer. It's used where the web is coated on both sides and for delicate webs that can't be mechanically supported or touched, including filter media and coated film. Non-contact web support eliminates issues with marking or scratching and eliminates the need for support rolls or a conveyor system. That gives you some cost savings there. An accurate and uniform control of dryer temperatures and ease of multi-zone operation. So for most applications, two-sided nozzles with balanced airflow are needed to stabilize the web. That also results in a higher dryer cost offset by the elimination of rolls and reduced overall dryer length. So you also reduce the maintenance of not having all of that conveyor to manage. You have lower rates of unit area transfer versus velocity compared with impingement, and a lowered velocity and flow balance required to float and minimize the sign effect against low lane tension may limit the heat transfer. So some of these might be a little bit longer. We also have through air dryers. We have rotary and flatbed types. This is typically for webs that require the heated air to be pushed through the material itself, and that's what it's normally used for. So it's for drying, curing, heat setting, and thermal bonding of porous materials such as nonwovens, textiles, paper, and fibers by the passage of heated air or gas through the material. That means it's really dependent on the material as to how the heat goes through it. In many thermal bonding applications, such as auto carpeting, cotton shoddy, or other recycled materials are mixed with low melt fibers such as polyethylene. It has 2 to 3 times higher airflow or heat transfer than conventional convection. Intimate contact with the product interior heats uniformly and very rapidly. High thermal efficiency for heating, cooling, or drying applications with high evaporation rates from a combination of both mechanical and thermal drying. The, the quality, of course, of the heating is dependent upon the permeability of the web and the conveyor. The wet to dry permeability changes in the web require multiple zones for efficient operation. So next, we're going to talk a little bit about industrial process infrared heating. So in general, infrared heating systems are more efficient with lower energy requirements for the same results when compared with convection type heaters. Energy is directly transferred from the heater to the target object for a higher heat transfer rate. It's available in electric or gas powered, both versions. And the heating temperature is dependent on the wavelength. So there's three basic wavelength types that are used for industrial infrared heating applications. And they are first shortwave emitters. Those are typically lamps from 2150 to 4000 degrees Fahrenheit. There's medium wave emitters, 900 degrees to 2150, and long wave emitters, 500 to 900 degrees Fahrenheit. And there on the right is a short diagram that shows the emitter temperature versus the wavelength. So for many of the applications, we want to tailor the wavelength to what is required by what is being heated. So some more characteristics of infrared dryers. They're used for industrial drying, powder coating, and paints, typically, for coating, annealing, filter media, nanofilms, battery, and fuel cell materials. So it's becoming more common, and as people find out more of the advantages for those specific applications. And again, it's really dependent on the application, which applications are better for infrared versus convection type methods. So for example, plastic for embossing, medium wave infrared directly heats and softens the surface quickly. For water-based coating on film, medium wave infrared directly heats the surface and is the most efficient wavelength for water evaporation. It's really tailored for water evaporation. Can be used for adhesives, impregnated fiberglass, and food applications, and can be used with or without air. So when air is used, air removes the steam generated by the heat and prevents the skinning effect, and also improves the efficiency of infrared. So the air actually acts really as a mass transfer to remove the water vapor and the steam away from the surface, which is important for a lot of applications, especially ones where there's a lot of water that is being removed. Some other benefits. Infrared heating systems are easy to zone for uniform heating of the product and width changes. Fast response to changing process conditions, including quick startup and shutdown in most styles of heaters. Lower initial capital and installation costs, including floor space savings, and that's a big one because they require less space for the same amount of heat transfer. And it's often added to existing conventional dryers to increase line speed. And one of the things I'll mention it again, one of the things that we do well and we focus on is improving existing processes and existing heating systems by adding infrared drying elements in the process, either to improve quality, improve issues that existing heaters have, and also to improve throughput of product through heaters. So a couple of specific issues for the electric type. The electric type has a wide temperature range, better turned down with infinite temperature control and tunability. So you can really dial in precisely the amount of heating that you need if you want to really control the quality of your end product. For gas heaters, you have a higher density of heat in a small area that allows the temperature and high temperature and high intensity heat in a small package. So up to 50,000 BTU per square foot. It also gives you more intensive medium wave heating, and it's often used to cure powder coatings on any substrate. So the choice of gas or electric might also be made by local energy costs. And we've even done some combination gas and electric to get specific qualities, specific process qualities that our customers have required. It is, however, essential to run trials in the lab or on a pilot line to confirm dryer sizing and the desired finished product quality. So there again, I want to mention that we offer a rental program that allows customers to deploy infrared heaters at a low cost to learn. And that's important because with any new technology like this, if you're not familiar with it in your plant, it's going to take some time to learn how to use it, how to tweak the temperature, and also how it affects the ultimate quality of the product that you're making. That's why we found that our customers like our rental program, so they can really learn the technology without actually having to commit to an entire heating system yet. Because they often learn things that changes some of the requirements that they initially thought that they had. Some coatings may not be able to take advantage of the higher rates of heat transfer and may skin and blister, and may be difficult to work with temperature-sensitive substrates. And also, since infrared is basically a surface phenomenon, sometimes it's harder to dry heavier coatings without overheating the surface. So here's a couple of our designs and styles. We have in the middle of the top there, medium wave open resistor style, and these are the type of elements that we make in-house, which we're very proud of. We also have quartz tube short wave on the bottom left, and also we can show our gas-fired heater types here on the bottom right. Let's talk a little bit about combination and hybrid dryer characteristics. Here on the right there, you can see a sample of a combination of convection and infrared heating elements really in the same unit. And we specialize in developing hybrid dryer processes, combining the best of both worlds. We have combination convection and infrared can be designed together for your application. Infrared is often added to increase line speed and productivity of existing processes. And we also, as I mentioned, a combination of electric and gas infrared. So many times our infrared heaters really have been used to solve specific customer quality problems. And there's a couple I just want to mention as we close out the presentation. We had one customer that had trouble with plastic bottle annealing, and so we had to strategically place infrared heaters in their process that were added to eliminate cracks during bottle handling. At another customer, preheating heavy commercial vinyl wallpaper, we installed IR heaters strategically in the process that were added to evenly heat the paper across the entire surface, and that greatly improved embossing quality. So those are the kind of, I wanted to point those out. Those are the type of problems that we solve as a company, and the things that we do for our customers in the heating space.